10, all right? 10.1 is a review of pre-calculus. It's about standard form of parabola, open up, open down, the standard equation form of circle, ellipse, and hyperbola. Please spend some time reading on that section if you don't remember. We did cover everything in pre-cal. So let's go to 10.2, all right? Plane curve and parametric equation. So let's say I'm giving these two equations. The first one is x equal to t squared. So thinking of the coordinate x at particular time. So think of t as a time and x is the x coordinate. Now my second equation is y equal t to the fourth plus 1. Again, this is we talking about particular time and particular position of the y as the object at different time. So these two equation is called parametric equation. Now I'm gonna rewrite it as rectangular equation. So like rectangular equation, I will eliminate the t, so we only have x and y. So for this example, I use substitution method. You can use any method that you learn from algebra, can be addition method, substitution method. So what I did is from 1, all right? From 1, I solve for t squared. My t squared is x over 2. Then I call it equation number 3, and then I substitute it in the second equation. So I would have a y equal, instead of t, I put x over 2 square plus 1. All right. So my equation will be y equal x squared over 4 plus 1. This is called rectangular equation. If you look at the equation, this is a parabola. Your a is 1, which is positive. It's going to open upward. If you substitute 0 for x, then y would be 1. So that's your vertex. So if you use the rectangular equation, you can just graph it like you normally graph the parabola. Now on this table, I put the table I have variable t, x, and y combined together. So t, think of it as time, and x is the x coordinate, y is the y coordinate. Let's concentrate on t greater than 0. 3 greater than or equal to 0. When t is 0, I substitute 0 here, so my x would be 0, as you can see. When t is 0 here, my y would be 1. So as t time, I use the green color. When t is 0, my x is 0 and my y is 1. Now let's look at when t is 1. When t is 1, x will be 2 and y also going to be 2. So object is moved from left to right. You can see the object move from the left side to the right when t is 0, and this when t is 1. And this is the position of the object at the x and y coordinate. So you have a parabola open upward, which is the same graph that we used if we use the rectangular equation. Alright, so let's look at the next example. I'm giving this parametric equation. X is equal to 3 cosine theta. I call it equation number 1. Y equal to 4 sine theta. I call this equation number 2. It's parametric equation, and theta is between 0 and 2 pi, including 0 and 2 pi. So what I'm going to do is I'm going to rewrite this as rectangular equation. So what is rectangular equation? Is rectangular equation, you're going to have only x and y only. So I have to eliminate the trig function. So what I did is the first equation I solved for cosine theta. Cosine theta is x over 3. The second equation I solved for sine theta. Sine theta is y over 4. And if you recall a trig function, cosine squared theta plus sine squared theta is equal to 1. I use a trig function here. And then I substitute cosine equal to x over 3, sine theta y over 4 into the the function here. Then I have x squared over 9 plus y squared over 16 equal to 1. Now this is a rectangular equation because I don't have a trig function anymore, only x and y. If you recall pre-cal or go back to 10.1, this is the standard equation for an ellipse. Alright, the standard equation of the ellipse is x minus h quantity square over b square plus y minus k quantity square over a square equal to 1. Now h and k is the center. Now I can rewrite this as x minus 0 quantity square, y minus 0 quantity square, which means my h is 0, my k is 0, so the center is 0, 0. This is a major axis is vertical because my A is greater than B. My A is with the Y, which is 4. My A is 4. My B is with the X, which is 3. Alright, so I have a major vertical axis. To calculate the C, the formula is C squared equal A squared minus B squared. So substitute this and solve for C. Your C is going to be 2.65. If you graph this from this equation, alright, the vertex is going to be 0, 4 and 0, negative 4. Because your A is 4, that's your vertex. Your minor axis will be B, which is 3, 0 and negative 3, 0. And then your focus will be 2.65. You have two of them, one over here and negative 2.65 over here, if you use the rectangular equation. However, I'm going to make a table here and I'm going to use parametric equation to graph this. Alright, the theta is between 0 and 2 pi, so I make it 0, pi over 2, pi, 3 pi over 2 and 2 pi. So the object is moved from here to here to here and to here. So let's say if theta is 0, I'm going to substitute in here. If theta is 0, cosine of 0 is 1, 1 times 3 is 3. Let's substitute the next one for my y coordinate. If theta is 0 for sine theta, so sine 0 is 0, 0 times 4 is 0. Let's try one more. Alright, let's try one more. Pi over 2, cosine of pi over 2 is 0, 0 times 3 is 0. That's how I get 0 here. Sine of pi over 2 is 1, 1 times 4 is 4. So I assume you can just fill the table on your own. So let's graph this. So when theta is 0, x is 3. You see it's right here. When the angle is 0, x is 3, so it's here. And y is 0. Now look at the green arrow. Then I move to pi over 2, so the object moves this direction. When an angle is pi over 2, x is 0, y is 4. And then an angle is pi, x is negative 3, y is 0. An angle is 3 pi over 2, x is 0, y is negative 4, and then 2 pi is over here. So it moves counterclockwise in this direction. And it's the same shape as ellipse if you use rectangular equation. It's exactly identical, the same shape. And later on we will learn how to do both, and sometimes it's easier to use parametric equation to graph, sometimes it's easier to use rectangular. Alright, so I'll see you next section. Bye.